demonstrate they know more about a topic than you do. And there's a time and a place for everything, right? So this is not the time or place to try to ridicule the speaker and try to prove that you know more about something than they do, okay? So they're volunteering to come up here and speak to you and share something with you. So it's basically rules of, treat others as you would want to be treated if you were up here speaking, okay? So that's the only rule for the listeners. Okay, so let's go ahead and kick it off. Vish wanted to be first. So Vish, why don't you introduce yourself as to tell us who you are and then get into your talk. Go ahead, Vish.
Hello, everybody. I'm Vish Puttagunta. You can call me Vish. And I'm the data scientist and technical program manager at Linaro. And Linaro is an open source company, and we work in the ARM ecosystem. We work in various domains, including enterprise, mobile, home, networking, and IoT. And we're built on open source, so we want to make sure that the Sparks of the world, the H2Os of the world, the Hadoops of the world work well on an ARM ecosystem. And I know that a lot of you haven't heard of even ARM in an enterprise as opposed to x86, but ARM servers are coming in, and we want to make sure that they're well supported out there in the community. So, what I want to do today, as I come, it's about 6th or 7th time I've been here, and there are a lot of good presentations that are coming up. And what I wanted to do is to share an oversimplified picture of what I do as a data scientist. And hopefully, and it's an oversimplified picture, so take it with a little grain of salt. And hopefully this will put things in perspective. And somebody comes and says H2O or Redis or or TensorFlow, hopefully this will help you to put things in a perspective. Give you, okay, I see how this fits into the grand scheme of things. So, to start with, right, as a data scientist, what is my end game here? And that's kind of important, because that doesn't change whether I work on a single computer or a cluster of 50 computers. It doesn't change. So what is my end goal? For the most part, I'm trying to predict the value, right? I mean, you give me a set of, go join a corporation or some company, and they basically say, I want to predict sales. I want to know what temperature I should set my thermostat to. So I basically come up with a model, right? So I'm trying to predict a real number here, right? So I'm trying to predict the value, or I'm trying to classify things, right? I mean, somebody shows me a picture. Is it a cat or a dog or a horse or something like that? Or they give me a whole bunch of data and say, hey, we ran these tests for this medical, I'm trying to drug, and does this work or not? So are you trying to, based on the data, does the drug actually work or not? I'm trying to transform things. Somebody gives me a vector in one dimension, and I'm trying to convert that into another dimension. For example, somebody gives me a sentence in English, and I'm trying to convert that into Mandarin or Hindi or something like that. I'm trying to find correlations, right? I mean, how well are Diet Dr. Pepper drinkers correlated well with how much do they eat meat or something like that? Find an interesting correlation like that. That provides a lot of value to companies. If they know that meat eaters drink a lot of Dr. Pepper, it's valuable for them. So I'm trying to find these correlations. And to do all this, I need to do a lot of wrangling, right? Because the data is all over the place. It's in the internet, sometimes out there. It's sitting in data warehouses. It's sitting in SQL type databases or NoSQL type databases. It's all over the place. But in the end, my goal is to make sure that I do these predictions, these classifications, these transformations. And that's kind of important, and I kind of feel that it's important to know, because that goal doesn't change whether I use a single computer or a cluster. Now, what are the tools that I have, right? I mean, what are the math tools that I have, and what are the software tools that I have? Broadly, I could classify that into 3 main categories, right? I mean, one is the classical statistics, right? I mean, the linear regressions of the world, the k-nearest neighbors, decision trees, principal component analysis, all these mathematics tools or statistics tools that have been there. I mean, they have been there for 30 years. I mean, some of them have been there for centuries, actually. And then there are a lot of these deep learning, neural network-based tools, right? I mean, where they kind of simulate a neuron of how it works, and they formulate all these neural network components into different formations, and they try to predict the same thing. But in the end, what are they trying to do? They're again trying to predict, they're trying to classify, and so on and so forth. So why is data science such a big deal right now? I mean, like, I can tell you last year I just went into LinkedIn and looked at data science. Dallas, not much, right? I mean, like, maybe California, a lot of jobs, but why is it such a big deal right now when these statistics have been there for such a long time? It's because of all the software tools, right? I mean, a lot of these tools have become very easy to use. A lot of these things have become open source. So that's what has driven, and also the processing has become cheaper, the memory has become cheaper. So that's what drove the whole industry forward. And this is my view of the world. I don't care what you give me, I see it as a table. On the right-hand bottom corner, I don't care what you give me. It's a bunch of X's, which are my features, and it's a Y, my target. What am I trying to predict, whether it's a value or a class? And this is overall generally true, right? You give me text, you give me numbers, I don't care. In the end, I'm trying to get a table, right? And here I just wanted to show you, like, for example, what are these X's, right? Like, for example, in the top left corner over there, somebody asked me, okay, I want to predict the sales, right? So I basically say, okay, how much did you spend on TV ads? How much did you spend on radio ads? How much did you spend on newspaper ads? And I'm trying to come up with a good model for that. So my target is that Y, sales, right? So that's a linear regression. I'm trying to basically fit a line. Or it could be a logistic regression, which is one of the classification techniques. Now, there are a lot more techniques, and there's a lot more depth to it. I don't have time to go through that right now. I have a 1-hour presentation for that. But the reason I put it all is because, in the end, it is just a bunch of features, and it's a target that I need to hit, right? That I need to predict. I need to build a model, and once I build a model, as I keep getting the exercise, I'm just going to predict what's, right? And this table could be 100 lines, 100 rows, or it could be 10 million lines. I don't care. Yes, my computer, if you give me one computer, I could probably do well with a million rows. But if it's like a 10 million rows or something like that, I need to start thinking about how to scale into a cluster. But my objective does not change. And that's the big idea that I want to get here, is the objective of a data scientist do not change. The scale does. So here are some of the tools that I just wanted to put out there, right? And again, think of like, what can I do? If you basically come up with a problem, right? Okay, I want to predict this. I want to predict sales or something like that. You give me a single computer. What will I do? All right, I'll load up my pandas and Python, and I'm very inclined to use pandas and Python because that's what it's an open source, and I like Python. I used a lot of MATLAB before, but these are like single computer tools, right? I mean, like whether it is R, SAS, MATLAB, those are the things that you give me data, or whether I'm pulling from SQL source or no SQL source or USB stick, I don't care. It is something that can fit in the RAM of my computer, and I can process the data, right? Then, of course, if you give me a single computer, I can only go so far. All of a sudden, if you have like terabytes of data or hundreds of gigabytes of data, I start running into limitations, right? But the thing is, my end game doesn't change. My end game is still to classify, it's still to predict, it's still to transform, right? But my tools change, right? Okay, I'll start going into a cluster kind of environment, right? In the end, that same data frame or a table, I represent it in pandas or R, or whether it's H2O or Spark, it's the same concept, right? So I'd like to spend a little bit of time on the cluster. Obviously you'll start to see tools. I mean, Spark is very popular, H2O is really popular. I'm pretty sure there are a lot of other tools that are coming out. But there's a subtle difference that I want to highlight. I think it's actually important. So in-memory tools versus on-disk tools. Like for example, when Hadoop came out, like 5-10 years ago, I guess. Sorry.
1 minute. Go ahead.
Okay. So yeah, this is the last slide. So when Hadoop came out, it's actually a map-reduce infrastructure, right? You think of any operation, like you say for example you have 1 billion numbers and you want to increase all of them by a 10. I can do that. I can scale it out and do it, right? But that's all it is. It's just a map and reduce infrastructure. I see a lot of executives coming and talking to me saying that, oh, we spent like, you know, $1 million on Hadoop, we didn't get any ROI on it. And I'm like, what is the end game? It's an algorithm. Show me the actual algorithm that's running on map and reduce. Map and reduce by itself doesn't give you any value. It just becomes another data store for you. So, but the good thing about now is that, you know, you have in-memory tools like H2O and Spark, and you can actually use them to do things a lot faster. And they not only are the infrastructure, they give you a lot more knobs than just map and reduce, like, you know, the filters. And the good thing about this is people are actually starting to write algorithms on top of it. Like, you know, you actually see linear regression, logistic regression, decision trees actually implemented on top of this infrastructure. And that's why Spark ML or an H2O becomes very important. And, you know, at the bottom is like, you know, NoSQL data stores. I could go into a lot more detail, but I don't think I actually have the time for that. But essentially, what I wanted to say is whether it's a single node or a cluster, my ideology doesn't change.
Yeah, so I forgot to say a couple of things. So the format allows for questions at the end, so that's why we kind of force you to wrap it up so that we can get to questions. So we have, you know, 3 to 5 minutes for Q&A at the end of every talk. So go ahead, Vish. Anyone has questions?
So any questions so far?